Okay, so after that long 40-minute video, this will hopefully be significantly shorter. But just so you know, I've already made some of the videos from chapters 8 and 9 and some of the later videos, and some of those can get pretty long too. So, um, at any rate, subtracting rational expressions is pretty straightforward actually. It is, all you do is you end up changing some signs, then you do some adding. I mean, essentially, you can think of it going straight from here to here. This is the base. I mean, this is the basic rule of subtracting rational expressions. The reason why I put this middle step in here is because it might be easier to think of it in terms of changing the middle signs from a minus to a plus, and then changing the signs of every individual term in the numerator for the second one. So I want to go ahead and go straight into an example so you'll see what I mean by that. So let's say we have 2x plus 5 over x plus 2 minus x plus 3 over x plus 2. So we already have common denominators. The next example will have an example where we don't have common denominators. So what I want to do then is I want to think of it in this aspect. I want to think of this as adding the opposite of C. And the reason why is because it's not uncommon to people to just say, oh, minus x plus 3, and then they'll subtract the x correctly, but then they will go ahead and add the 5 and 3, and that's not right. So I'm going to change this from a minus to a plus, and then change the sign of everything here. So I'm going to go ahead and rewrite this using that concept. So 2x plus 5 over x plus 2 plus, see, now I'm doing a plus instead of a minus, minus x minus 3 over x plus 2. So see, all I did here was I changed the minus to a plus and then changed the signs of every individual piece. So now I can go ahead and add across just like I'm adding two different fractions. So now this is the same thing as 2x plus, plus 5 minus x minus 3 over x plus 2. And now I can combine like terms. I'll do that on the next line here. So so now I can combine this 2x and this minus x to just make x, because 2x minus x is just going to be x, and then this, so when we're done with this, and then this plus 5 and this minus 3 is just going to be plus 2 all over. The denominator stays the same, x plus 2, also the equal sign. And then this x plus 2 will cancel out with itself, so all you have left is 1. Also remember that, this is, I guess you probably already noticed this, but whenever you change the sign, you only change the sign of the numerator, not the denominator. Okay, so let's go on to another example. What if you don't have the same denominator? It's pretty much the same thing as if you're adding. So let's take this example, 2x minus 5 over x minus 1 minus x squared minus 3x minus 7 over x squared plus x minus 2. Okay, so the first thing I want to do, as usual, is I want to figure out what I want to make these two denominators the same. So that means that I want to factor out everything that I can. Can I factor out this denominator? No, I can't. What about this one right here? So we'll have this x squared plus x minus 2. That'll be the same thing as x plus 2 times x minus, well, sorry, bad writing, x minus 1. What about this top part right here? Well, to find the lowest common denominator, we don't really need to factor out the top part, but I will say one thing that's pretty important. This actually can't be factored out. And the reason why I know that is because there are no two numbers that multiply together to make -7 and add together to make -3. You can try that out, and hopefully that'll make sense to you. So, because to factor this out, you'd have to have an x plus something times x minus something. So you'd have a positive number and a negative number that multiply to make -7. Well, -7 is a prime, so it's going to be either 1 and -7 or 7 and -1, but neither of those add up to make -3. So that means that this can't be factored using whole numbers. So let me go ahead and rewrite this expression using this factorization. So we have 2x minus 5 over x minus 1. This left one doesn't change at all. And then we have x squared minus 3x minus 7 over x squared. Oops, I forgot the factorization. X plus 2 times x minus 1. So this factors into this. All I did was replace it. So now we think of what's missing from either of these to get the lowest common denominator. The lowest common denominator, hopefully you can see this, is just going to be x minus 1 times x plus 2, because there's at most one x minus 1 and at most one x plus 2. So this one already has the LCD. This one does not. It's missing the x plus 2. So I'm going to multiply top and bottom of this left one by x plus 2. So I know I'm going kind of fast for this, but if that doesn't make sense, you can go ahead and watch the previous videos about finding the LCD of it was this same section. It was just that it's an earlier video finding LCDs of two different fractions. So then we'll have 2x minus 5. I'm just multiplying the top and bottom of this by what's missing, and that'd be x plus 2. So 2x minus 5 times x plus 2 over x minus 1 times x plus 2. I'm not going to multiply this out. I will multiply the numerator out in just a little bit, but for right now I'm keeping this denominator the same. Minus. It's still a minus in between. So then this x squared minus 3x minus 7 over x plus 2 times x minus 1. Okay, so now we have the same denominators. I'm going to go ahead and multiply these two binomials out, and we will get 2x squared. Whoops, what did I do here? Sorry. 2x squared 2x squared times plus 4x. Oops, that's on the outside of the fraction. Plus 4x minus 5x minus 10. Okay, I'm gonna have to move this to the left a little bit. So, and then this, you'll still have the still have it over x plus x minus 1 x plus 2, and then you'll have the same fraction on the right. I'll go ahead and switch to the, sorry, I accidentally changed the setting. So I'm going to go ahead and go to the next line after this one. I didn't mean for it to go this long. So we have x squared minus 3x minus 7 over x plus 2 times x minus 1. Okay, so let's go ahead, and I'm going to just make a line break right now. Okay, here we go. So now I'm going to go ahead and change this minus to a plus and change the individual signs of each one. So make this to a plus, minus, plus, plus. So I'm going to go ahead and write that out more formally on the next line. Not formally, I just mean like type it out. So it will be change that plus to a minus to a plus. Okay, so plus, minus, plus, plus. Okay, so I just changed this minus to a plus, and then changed all of these parts to their opposite signs. So this was a plus, it became a minus. This was a minus, it became a plus. This was a minus, it became a plus. Now I can go ahead and add across. So this can become, I can put all of these on the same fraction. We'll have 2x squared. Oh, and I can go ahead and combine these two like terms. I could have done that earlier too. Minus x minus 10 minus x squared, because I'm putting these all on the same line, plus 3x plus 7, and then all over x minus 1, x plus 2. Oh, and of course there's the equal sign at the beginning. So I'll go ahead and clear that off. Now we combine like terms again. So we have this 2x squared minus x squared. That'll make this just x squared. And then this minus x squared plus 3x. I said squared here, I didn't mean to. Minus x plus 3 will give you plus 2x. And then this minus 10 plus 7 will give you minus 3. And then still all over x minus 1 times x plus 2. And of course this is all equal. So now we think, is there any way that we can factor this out? Well, it can be factored out to negative 1 and positive 3. So x minus 1 times x plus 3. Because these two things multiply to make negative 3, and they add to make positive 2. And this stays the same. X minus 1 times x plus 2. Now we have something that we can cancel. We can cancel this x minus 1. So our final answer then will be x plus 3 over x plus 2. This will be our final answer. Okay. That still, it ended up being a longer video than I meant for it to be, but hopefully it's at least shorter than 40 minutes like the last one was. So I will see you in section 7.5.